So we are going to take a look at molar concentration. We're going to use some of the terms that you would have read about in the presentation of Intro to Solutions and Solubility material. And so we'll just get right into it. We'll do a couple of examples that aren't in the notes, and we'll just work through it. So molar concentration, when we talk about molar concentration, we are talking about C equals N over V. Now, the key here with the concentration, when we're dealing with a solution, there are many ways you can make a solution. You can dissolve an ionic substance into a liquid. You could dissolve a molecular substance into a liquid like water. A lot of different ways. But there are, based on that, we can look at how we can talk about molar concentration. So molar concentration deals with a quantity of moles divided by volume. So that's our moles of solute typically. And on the bottom of that fraction is always the volume of solution. And that always is in the unit of liters. Okay, our moles obviously has the unit moles. So when we're dealing with concentration, we're going to have moles divided by liters as our unit always for our molar concentration. Now, going back to examples, if we were to take an ionic substance and put it in water, that ionic substance dissociates. But we can talk about how much of that ionic substance is in the total solution, and that's a concentration. It's always dealing with an amount of solute divided by the solution. So in a molar concentration, we always want the moles of the solute divided by the volume of the solution. And that's what we look for and what we'll see when we're dealing with all of these particular problems. So let's try tackling a few. So if we take a look at this first example I've got written down here, it says 27.5 grams of magnesium chloride is dissolved in water to make 250 mils of solution. Determine the molar concentration of the solution that was created. So if we know we want molar concentration, right, we know we want this value, and we know that that is going to be C equals N over V. That's the goal that we're getting to. We need moles, right? So we need to figure out moles of magnesium chloride. So we want N for this. We know this 250 mils is our volume. So if we can figure out moles, we've got our volume, we'll be able to find a concentration. So remember moles, we've looked at this already. We can use mass and divide it by molar mass to figure out what our number of moles of a substance is. So if we have 27.5 grams divided by the molar mass of magnesium chloride, so we use our periodic table to get that. We just add up all of the elements that are in that particular magnesium chloride, which is 1 magnesium and 2 chlorine atoms. We would get a molar mass of 95.21. Okay, so when we have our molar mass and our mass, we can find moles. And we will get 0.2888 moles. From this calculation, we're carrying 3 significant digits, so I'm just going to underline that so I remember that for later. Now, as we said, when we do C equals N over V for our concentration, we've got moles, we've got volume, but the key here is we want our volume, we want to convert it to liters. So this is 0.2500 liters. So in my calculation, I'm going to take my 0.2888 moles and divide by 0.2500 liters. And that will allow us to figure out our molar concentration, which on our calculator, it's going to spew out 1.15534. But for significant digits, our concentration, we want to make sure that we look at our significant digits. We carried 3 from our moles, and our volume had 4 significant digits. So our answer, because it's multiplying and dividing, should have the smaller number, which would be 3 significant digits. So this would be 1.1, oh, I almost didn't round right, 1.16 moles per liter. Okay? Moles per liter. Man. And that would be our answer. Okay, so this is how we can tackle our problem, right? Find moles, use the moles and the volume to find concentration. Pretty straightforward. Let's take a look at one more example. This example here is more typical to probably how you would be using this calculation when you're working in a lab. If you're doing any work, you're usually trying to figure out what mass of a substance you're going to put into water in order to make a specific solution. So that's what this question looks at. It says, what mass of aluminum nitrate would be required in order to create 2 liters of a 1.25 molar solution? So let's think about that. If we want mass, we can find mass is equivalent to moles times molar mass, right? So mass is just this particular value. Molar mass we can get from the periodic table. Moles we can get from a concentration, right? And we know that concentration is N over V. So this equation can be rearranged to find moles. Once we've got moles, we can plug it into this equation to find our mass, and then we're done. Now, one thing we have to make sure is we end up with the right formula for aluminum nitrate. Aluminum nitrate has this formula, right? Because that's important, having the right formula to get the correct molar mass to end up with the correct value for our answer. So let's tackle this. Now that we know what we need to do, we want to take C equals N over V, and we're going to rearrange it to get N. So N equals C times V. And then we can take our concentration, 1.25 moles per liter. And if you ever see this unit, capital M, a unit for a number, capital M, that stands for moles per liter. It's just a short form for moles per liter. And we're going to multiply that by the volume, which is 2 liters. And we will get our moles, which in this case is 2.5 moles. And that's to 2 significant digits from our volume measurement. Now we've got moles, we can find mass. So mass is moles times molar mass. So we're going to say 2.5 moles times our molar mass, which ends up being 213.01 grams per mole, right? So that's found by adding aluminum, 3 nitrogens, and 9 oxygens together. That's where that 213.01 comes from. So when we do the math to find the mass is going to be equal to 532.525 grams. But based on our significant digits, this value has 2, my molar mass has 5 significant digits, so my answer needs to have 2 significant digits. So I'm going to write this in scientific notation, 5.3 times 10 to the power of 2 grams. And then I've got the proper 2 significant digits that I need for this measurement. So this is my answer. That's the mass I would need. I would need 5.3 times 10 to the 2 grams to put it into that solution to create the right concentration. So I'll just finish up with my statement. There we go. And that's it. So that's our problem for finding a mass given concentration information. The key is just find those moles and then work with your molar mass calculation. And that's it for this lesson. Thanks very much.